is Albert.
My name is Laura.
And I'm Tarina.
And we're the digital media class doing Newton's third law.
Hello, my name is Naisha.
My name is Charles.
And I'm Demal.
And we are the physics class, and we're doing Newton's third law.
Newton's third law states that for every action force, there is an equal and opposite reaction force. These forces act on different objects. In this video clip, two students are demonstrating Newton's third law in motion. We have Demal on the right and Albert on the left. Both are sitting in rolling chairs. When Albert pushes on Charles' knees, he is generating the action force. At the same time, Demal is generating the reaction force by accelerating away from Albert. As you can see, both forces are equal in size but moving in opposite directions.
This illustration shows how the small car is exerting a certain amount of force into the big car, and at the point of impact, the big car is exerting the same amount of force back into the small car.
When swimming in a swimming pool, our hands and legs exert a force on the water by pushing the water down and backwards. The water, on the other hand, also exerts an equal and opposite force on the swimmer by causing the swimmer to float and also pushing the swimmer forward.
As we all know, Newton's third law consists of the fact that when an action occurs, an equal and opposite reaction occurs as well. For instance, this picture shows a balloon with air propelling downward and the balloon is going up. When the action of air rushing out of the balloon takes place, the reaction is that the balloon is forced away. Since the formula for calculating force is F equals ma, where force is equal to the mass of an object multiplied by the amount of acceleration applied to the object, this is true for the balloon example. The force of the air moving out of the balloon is equal to the force of the balloon being pushed away from the air, but how fast the balloon is pushed away from the air is determined by the speed or acceleration of the air being pushed out.
In this diagram, as the hammer hits a nail and drives it into a piece of wood, the hammer exerts a force on the nail. The nail also exerts a force on the hammer as well. This is what stops the hammer and keeps it from going through the nail.